Hello, ladies and gentlemen. Okay, today we're going to talk about quadrilaterals, but more specifically, we are going to talk about the quadrilaterals trapezoids and kites. Okay, so you're going to need that foldable we've been working in. We're going to talk about these trapezoids and the properties of them, as well as kites and the properties of kites. So you're probably going to want that foldable. You're definitely going to want a calculator and something to write with. All right, so trapezoid. First thing you want to get written down is the definition, and the definition of a trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. So when I say exactly one, that means we only have one pair of opposite sides parallel. So our first property then is exactly one pair of parallel sides. So when you mark up your picture to the right, again, when we mark up parallel, we put the arrows or the triangles. Okay, so I'm going to mark it up with those arrows. Okay, the next property we have is the median. Okay, so in yours it's drawn in, so I'm going to quickly draw it in here. So the median then, sorry for my line not being very straight, but the median then is going to equal 1/2 B1 plus B2, or 2 times the median is going to equal B1 plus B2. So I would get both of these formulas written in. Again, they're the same thing. I'm just writing it in a way that makes more sense, or to you might make more sense, maybe not, but I would jot down both of these formulas. Okay, and so we're not necessarily going to mark it up on our picture at all, but we are going to make sure that we write down both of those formulas because we are going to need to use it in our examples. So let's start those. All right, so in example 1 here, we need to find the value of x. So if you notice, we're talking about this angle here and then this angle down on the bottom. Since we have a set of parallel lines here, we can say that these two are supplementary, okay? This is not necessarily something that was in our properties, but we could add it in there, okay? But when we talk about the sides, when we're talking about the side angles here of trapezoids, they're always going to be supplementary. So when I set up an equation to help me solve this, I'm going to write 12x plus 3 plus 13x plus 2 equals what? Okay, supplementary again equals 180. So we're going to set both of these angles equal to 180. Now when I do the math and solve, I'm going to add like terms, so 25x plus 5 equals 180. So I'm going to subtract 5 from both sides. So 25x equals 175. And when I use my calculator to solve, divide both sides by 25, I get x equals 7. And that would be the answer to this first example. Okay, next we're going to go over here to our example 2. I'm going to start by labeling. So AB is 7y plus 6. EF is 5y minus 3, and DC is y minus 2. Okay, now since I'm using the median, I would probably use that formula. I'm going to use the first formula we gave you, but you're going to see what happens if you use the second formula. It might save you a step. So median, so the formula is the median equals 1/2 B1 plus B2. So the median in this example is 5y minus 3. We're going to leave that 1/2 there. B1, it doesn't matter which one's B1, but I'm going to use y minus 2 plus B2, which is 7y plus 6. Okay, now I'm just going to add like terms. So 5y minus 3 is going to equal 1/2 8y plus 4. Okay, now in order to get rid of this 1/2, I could either multiply it in or I could divide by 1/2, which is essentially the same thing as multiplying by 2. So that's why our other example says 2 5y minus 3, our other formula, equals 8y plus 4. Again, you could have distributed it in here too if you wanted to, but I'm going to multiply both sides by 2. So then I'm going to get 10y minus 6 equals 8y plus 4. So when I then combine like terms, I'm going to take the y's to the left-hand side by subtracting 8y to get 2y equals, I'm going to take this 6 and move it to the other side to get 10. When I divide both sides by 2, then I should get y equals 5. And that should be your final answer. Again, if that doesn't make sense, you could divide, or you can multiply that 1/2 in, or you can multiply both sides by 2. It depends on which formula you're using. Again, that's why I said you could use the formula 2 times the median equals B1 plus B2. So you could have started by using that formula as well, but I started using the original formula that they gave us. All right, so definition of isosceles trapezoid then is a quadrilateral with exactly one pair of opposite sides parallel and congruent legs. So again, since it's a trapezoid, it's going to have the same two properties of a trapezoid. That's going to be exactly one set of parallel sides, and the median is going to be 1/2 B1 plus B2. Okay, now a couple of new ones. Since it's isosceles, we know that the legs are going to be congruent. Okay. We also know that those diagonals, if I were to draw in the diagonals here, so draw them in, sorry if they're not perfect here for you. Oops, those diagonals then are also going to be congruent. And lastly, the base angles are going to be congruent. So I'm going to draw those in by using my arches. Since it's isosceles, the base angles are congruent and our diagonals are congruent and the legs are congruent. Okay, so making sure you get all this written down. And we're going to move on to a couple examples. All right, in example 3, done is an isosceles trapezoid where the measure of EDO, so this measure right here is going to be 110 degrees, and the measure of angle DEN, so this angle right here is going to be 15x minus 5. So similarly to example 1, these are going to be supplementary because they're on the same side of that trapezoid. So when they're on the legs, since I have parallel sides on top and bottom here, these are going to be supplementary, meaning they equal 180. So 15x minus 5 plus 110 has to equal 180. So let's combine like terms. 15x plus 105 equals 180. We want to get x alone, so I'm going to subtract 105 from both sides to get 75 on the right-hand side. And when I divide by 15, we should get x equals 5, I believe. Okay, so that would be the answer for that first one. Now, in our next example, we have trap is an isosceles trapezoid if PR, so the first diagonal is 3x minus 7, and TA is 20. Okay, since we're talking about diagonals, we have a property that tells us that the diagonals are congruent, and congruent means equal. So it looks like I'm going to take 3x minus 7 equals to 20 because my diagonals are congruent, and here we're talking about diagonals, that's why I'm using that equal sign. So then this just becomes an algebraic problem where I'm going to add 7 to both sides to get 3x equals 27. Divide by 3, I should get x equals 9. Okay, again, those are our trapezoid properties. Okay, so making sure that you jot down any questions you might have because you will have an exercise to do in class using these properties. Okay, so Kite, remember we don't have anywhere in our foldable, so you're either going to want to jot this on the back if you're not going to glue it into your notes, or if you are going to glue it into your notes, write this somewhere in your notes next to where this is going to get glued in. So definition of a kite. Again, take your time to write these down. Is a quadrilateral with two pairs of adjacent sides which are congruent. So adjacent, again, is just meaning touching. Okay, so again, jot this down, draw on this picture. Now the first property then is going to be two pairs of adjacent sides are congruent. So just by looking at this, it looks like these top two are going to be congruent and then these bottom two are going to be congruent. And adjacent means they're touching, so they do touch at these top and bottom vertices. Okay, the next property we're going to want to get written in is that their diagonals are perpendicular. So first off, let me draw in these diagonals. So if I draw in these diagonals, again, you're going to want to draw this in as well. Diagonals are perpendicular, and again, perpendicular means forms 90-degree angles. So let's draw in that 90-degree angle. The next property we have is the diagonal that connects the top and bottom vertices is going to bisect the opposite angles. So bisect means cut in half. So if I were to draw that in, these two angles right here are going to be congruent. And then these top two are also going to be congruent because it's just this vertical diagonal that's going to bisect opposite angles. And the last one we have is that same diagonal is going to bisect the other diagonal. So it's going to split this other diagonal into half as well. So making sure that you either pause this video if I went too fast so you can get down all of these properties, and then we're going to move on to an example that you will also have to jot down in your notes. All right, so our example here is you're going to have to jot this down again, okay? So here we have that kite, and now PQRS. So PQ and QR are equal, so they're both going to be 10. So I'm going to jot that in. PR, the whole thing is 16, so I'm going to try and jot that in as neatly as possible. So that whole thing is going to be 16, and RS is 12. Okay, so I'm just jotting in what they told me or what they gave me. First thing they want me to figure out is TR. So TR is just this little section right here. So T to R. Okay, what does TR equal? Well, TR is part of my second diagonal here, and we know that the diagonal from Q to S is going to bisect that other diagonal. So if it bisects 16, that means it's going to cut 16 in half. So TR is going to be 8. Okay, so I'm going to just jot that in here. That one's going to be 8. Next thing it wants me to find is Q to T. So Q to T right here, I'm going to make that an X because we don't know exactly what Q to T is. We don't know that this vertical diagonal is bisected. So here's where we have to do a little bit of math to help us figure out. If we were just to look at this triangle that I have created now, that I'm going to outline in green, if we were just to look at this triangle, if I were to take that out and draw it maybe over here, we know that this side is 10, and this side is 8, and we need to find this one. We also know that this right here is 90 because my diagonals bisect or are perpendicular in a kite. So if I have a triangle where I know two sides and it's a right triangle and I'm trying to find the third, I hope the red flag going off in your brain is that we need to use the Pythagorean theorem to help us solve this. So x squared plus 8 squared has to equal 10 squared, and 10 is my C value because it's the hypotenuse. So I get x squared plus 64 has to equal 100. X squared has to equal 36 when I subtract that 64 to the other side. If I take the square root of both sides, x is going to equal 6. So when I fill that in up there, QT should be 6. Okay, now we're going to do the same kind of process then to help me solve for TS. So TS is right here. Okay, so again, we're going to want to use this triangle right here. If I were to draw that triangle in over here, we know the top part is 8. We have a right angle here, right angle here. Oops, draw that in, right angle. Okay, and then over here, we're going to have TS, which is our unknown, so I'm going to make that our Y. And then we know that the hypotenuse is 12. So similarly, we're going to type in, okay, y squared plus 8 squared equals 12 squared. So y squared plus 64 equals 144. Y squared, when I subtract 64, should equal 80. And here it says simplest radical form. We'll ignore that for now. Let's just do the nearest hundredth. So 2 decimal places, so square root of both sides. When I type in the square root of 80 into my calculator, we should get back 8.94. So y is approximately 8.94, which means TS is approximately 8.94. Okay, next thing we want to find is QS. So QS is the whole diagonal then. Okay, but we know what x and we know what y is. So if I take 6 and I add it to 8.94, we should get 14.94. Okay, since QS is the whole diagonal, I used what I found in previous examples to just add those together and then solve from there. Okay, the next thing then, if the measure of QRT, so QRT is 40, and here this is going to be 40 degrees. Sorry, this picture is getting a little sloppy. We need to find the measure of PQR. So we need to find the measure of this whole angle here. Well, we should be able to figure out this angle. Since it's part of this triangle, we know that every triangle has to equal 180. So if I were to do that, this part right here is going to be a 50-degree angle. Okay, but then we know that this diagonal Q to S is going to bisect this top angle Q, so that means this other side has to be congruent to that 50. So now when I'm talking about the whole angle, I take both of those and I add them together to get 100 degrees. Okay, again, using the properties that the diagonal going vertically bisects opposite angles, then I could just double this to get 100. Okay, now lastly, the last thing, PSR. So PSR, this whole thing right here is going to be 30 degrees. We need to find TRS. Okay, so we want to find this little angle right here. That's my unknown. Again, this vertical diagonal is going to bisect that bottom angle and the top angle. So this little angle in here is just going to be 15 degrees. Then when I have a triangle, again, I'm going to pull that triangle out so we can maybe see it a little bit more clearly. The bottom angle is bisected, so it's going to be 15 degrees. Here I have a 90 degrees because the diagonals are perpendicular. How can I find this missing angle? Well, again, degrees in a triangle add up to 180 degrees. So how am I going to find that? We're going to take 90 plus 15, and then we're going to subtract that from 180 to get 75 degrees. So TRS is going to be 75 degrees. Okay, I just threw a lot of information at you people. So making sure that you jot down any questions you have and do your worksheet to the best of your ability. We can answer questions when we get back to class, or when I come back to class if you have any questions. All right, so I want to thank you for taking good notes, and I will see you when I see you.